In this video, we're going to take a look at how we can classify reactions based on what's occurring so that we can understand what changed and even predict what's going to be made. So remember, in a chemical reaction, we start with reactants, we start with something that changes and new bonds are formed, and we end up with products that are different than what we start with. And we're going to look at what we start with, what we end with, how they changed, and classify reactions based on that. So this is a pretty straightforward process. We look at what we started with, what we end with, and we figure out how it changed. We're going to examine a few different reaction types. Synthesis and decomposition. These two are easy because they are reverses of each other. Synthesis puts things together. Decomposition tears stuff apart. Single replacement and double replacement are similar in that you have elements switching places in compounds. And then finally, combustion is just a reaction with oxygen. So let's start with synthesis. Okay. Synthesis means bring together. You probably heard of photosynthesis, in which plants bring together carbon dioxide and water to build up sugar. Well, in a synthesis reaction, two or more substances, and by substance I could mean element, I could mean compound, either one is okay, combine into a single compound. And it does have to end as a compound since two things are coming together. So this is a generic version of it. A could be an element or a compound, B could be an element or a compound, and then AB is the compound of these things. So a common example of this would be if you take sodium, Na, and react it with chlorine, Cl2. Now remember, chlorine, the element, is Cl2. It's one of the diatomic molecules. Remember, the diatomic molecules are bromine, iodine, nitrogen, chlorine, hydrogen, oxygen, and fluorine. Brinkelhoff. Those things, when they're not in a compound, they're always bonded to themselves. So sodium reacts with chlorine to produce sodium chloride, NaCl. Okay. This chemical reaction shows me that the element sodium, which is a metal, reacts with the element chlorine, which is a gas, to produce the ionic compound sodium chloride. Okay, it doesn't go into how the bond forms. You guys know that. The reason sodium chloride has the formula NaCl is because sodium has one valence electron, chlorine has 7. And when the bond forms, this electron comes here, this becomes positive, this becomes negative, and these two stick together as sodium chloride. Of course, there's two chlorines here, so I'd need to have two chlorines over here, and we'll get into balancing things later, but that would be the actual chemical formula for this, or the chemical equation for this reaction. One thing combines with another to make a single compound. All right. Decomposition, well, decompose means to break down. So one compound breaks into two or more substances. And again, a substance could be an element, it could be a compound. So this is just the reverse of a synthesis reaction. So if we start with a compound, say H2O2, this is hydrogen peroxide. It can break apart, and in fact it does this. If you've ever had peroxide on a cut or something, it bubbles and fizzes. It breaks into water, H2O, and oxygen, O2. Okay, so we started with one compound that was bubbly and fizzy. We ended up with oxygen gas, hydrogen, and oxygen. Of course, we would want to balance this reaction, and I know how to do that. There's two oxygen atoms here and two over here, but then there's one more here. So I'm not going to get into this quite yet, but the reaction actually happens more like this. So two molecules of hydrogen peroxide break apart into two molecules of water and one molecule of oxygen gas. But we did start with one substance and end with two different things. So this is a decomposition reaction. Single replacement reactions are exactly what they sound like. One thing is going to replace another in a chemical reaction. And these typically involve a metal and a compound. Single element and a compound. I guess it doesn't have to be a metal. The general formula for this is something by itself plus a compound reacts to produce something that used to be in the compound, right? B used to be bonded with C, but now it's split off from that. It's all by itself, and so we get a different compound. So a classic example of this is a reaction if you take magnesium metal and react it with hydrochloric acid. You actually get something new and different. This will bubble and fizz because it produces hydrogen gas, and it will also produce a white solid compound called magnesium chloride. And Again, the chemical formula doesn't show me how the bonds break or form, it just shows me that they broke and formed and I got new stuff. So what was the single replacement that occurred? Well, the magnesium started by itself and hydrogen started bonded to chlorine. After the reaction occurs, hydrogen is now by itself and magnesium is bonded to chlorine. So magnesium kicked hydrogen out, hydrogen came and hung here, and we got magnesium chloride together. So the magnesium replaced the hydrogen in the compound with chlorine. This is one replacement because there's the magnesium atom is going to replace the hydrogen atom in this compound. And again, if I was going to balance this, we would need twice as much acid as magnesium. And then double replacement is the same thing but bigger. Instead of an element and a compound, we're going to have two compounds. So the positive ions of these two compounds switch places. Remember, the positive ions, the cations, are written first. So AC are positive, B and D are negative. So A used to be with B and now it's with D, and then C used to be with D and now it's with B. So these two swapped. Since there's two compounds switching positive ions, we call it a double replacement reaction. A typical example of this is actually one that you guys could carry out in a lab. Aluminum chloride, AlCl3, will react with sodium hydroxide, NaOH. Okay, remember OH is a polyatomic ion, hydroxide, so we treat it as one thing. This will produce aluminum hydroxide, AlOH3, and sodium chloride, NaCl. Okay, so aluminum used to be with chlorine and now it's with hydroxide. Now you'll notice I wrote this different because I have aluminum first here and aluminum first here. That's okay. Aluminum used to be with chlorine, now aluminum is with the hydroxide. So there's one replacement. Okay, the other replacement is when sodium used to be with hydroxide, now it's with chlorine. So these two things switched places. I ended up with aluminum hydroxide and sodium chloride. And I'll get 3 of these and 3 of these. Okay, so double replacement reaction, not that bad. Generally, if you have two giant compounds that you're starting with, two giant compounds that you end with, see if it's double replacement by seeing if the ions switched who they were with. Okay. The last reaction to look at is a combustion reaction. Combustion reactions are reactions with oxygen. Combust means to burn, and for burning something we need oxygen. And we have to have a fuel, and then we have to add oxygen, and then a spark, and then we have fire, which is combustion. And what we get out of combustion is generally CO2, carbon dioxide, and water. Okay, so if you take a simple fuel like methane, which is CH4, and you react it with oxygen, O2, you get out of that carbon dioxide, CO2, and H2O, water. So this is a chemical reaction, started with this compound, reacted it with oxygen, ended up with carbon dioxide and water. There is an exception to that. When a metal reacts with oxygen, it's just a single fuel. So M here is for metal, not for any particular element. And so if you take, say, iron and react it with oxygen, again, remember oxygen all by itself is O2 because it's a member of Brinkelhoff. It's a member of those diatomic molecules. Okay? When iron reacts with oxygen, depending on which iron you have, which iron ion you have, you could get FeO, and this would be iron oxide. This is technically a combustion reaction since it is a reaction with oxygen, but you could also argue it's a synthesis reaction because two things came together to make one. The one thing you have to be careful on is a lot of times students will tell me this reaction right here is a combustion reaction because it's got oxygen in it. But this is not a reaction with oxygen. This is a reaction to produce oxygen. So if oxygen is a product, that doesn't matter. Oxygen has to be a reactant in order for a reaction to be considered a combustion reaction.